In the previous lessons, every scheme was built on top of carrier amplitude. Now we change the rule. We keep the amplitude constant and push the message into the angle of the carrier. The angle has two natural handles, frequency and phase. That single decision splits into two related schemes. Frequency modulation, or FM, lets the message control the instantaneous frequency. Phase modulation, or PM, lets the message control the instantaneous phase. Both belong to the angle modulation family. The key idea behind angle modulation is the concept of instantaneous frequency. Imagine a pure carrier oscillating at a fixed rate. When the message rises, we make the carrier oscillate slightly faster. When the message falls, we make it oscillate a bit slower. So at every instant, the carrier has its own local frequency that follows the message. The amplitude never changes, only how fast the wave advances in time. That is why an FM waveform looks compressed in some places and stretched in others, even though every cycle keeps exactly the same height. FM and PM look very similar on a screen, but they encode the message differently. In frequency modulation, the instantaneous frequency deviation is proportional to the message itself, so a louder message pushes the frequency further away from the carrier. In phase modulation, the instantaneous phase deviation is proportional to the message. That subtle change makes PM equivalent to applying FM after a derivative of the message. In practice, FM became dominant in broadcast and voice radio, while PM appears more often as a building block inside digital communication. Inside FM, one number controls how aggressive the modulation is, the modulation index, written as beta. When beta is small, only a small frequency deviation is used, and the spectrum looks almost like AM with a single sideband pair. This is narrowband FM. When beta grows, the carrier swings far in frequency, and the spectrum opens up into many sideband pairs around the carrier. This is wideband FM. A larger beta improves audio quality and resistance to noise, but it always costs more bandwidth. To wrap up, FM and PM trade simplicity for noise resistance and quality. The bandwidth is no longer just twice the message bandwidth. A practical rule of thumb is the Carson approximation. The FM bandwidth is roughly twice the sum of the peak frequency deviation and the highest message frequency. So a wider deviation buys cleaner reception, but it always costs more spectrum. In the next lesson, we look at how to actually demodulate FM and how a receiver locks onto a carrier with a phase-locked loop, or PLL.